Dear students, we have learned that a stationary charge produces electric field around it and a steady current in a conductor produces a magnetic field around it. Also, Maxwell showed that an accelerated charge produces both the electric field and magnetic fields varying with time, and these fields propagate in the form of wave called electromagnetic waves. If we consider a charge oscillating along y-axis, the oscillating charge produces an oscillating electric field along the direction of the oscillation of charge, that is along y-axis, and propagates along the x-axis. Here the frequency of electric field is equal to the frequency of the oscillating charges. This oscillating electric field produces oscillating magnetic field along the direction perpendicular to the oscillation of electric field, that is along positive z-axis. According to Maxwell's equation, time-varying electric field produces time-varying magnetic field in its perpendicular direction and vice versa. That means time-varying magnetic field produces time-varying electric field. And it propagates along x-axis. The advancement of electromagnetic wave is given by the direction E cross B, where E is the instantaneous electric field and B is the instantaneous magnetic field in the electromagnetic wave, which is also the direction of Poynting vector S is equal to 1 by mu 0 E vector cross B vector. Thus the electric field and magnetic field also oscillating in same phase regenerates each other and propagates along the x-axis. You see, the electromagnetic wave is a progressive wave and whose electric field, if it is along positive x-axis, then we write E electric field, that is instantaneous electric field E vector is equal to E0 cos within bracket ky plus omega t bracket close into I, where E0 is the amplitude of the electric field, k is the value 2 pi by lambda, where lambda is the wavelength, and this is wave constant v, and speed of wave v is equal to omega by k, frequency is omega by 2 pi, and where speed of electromagnetic wave is E0 by B0, and refractive index of the medium is C by V. So what I want to emphasize is, look the electromagnetic wave as a progressive wave, and for any progressive wave we will have the similar expression of wave as we have used for the progressive waves. We will have similar expression for the expression of electromagnetic waves, which is in the which is a progressive wave itself. Now, thus we may finally conclude that a moving charge produces magnetic field, and an oscillating magnetic field is produced by an oscillating charge. This gives rise to an oscillating electromagnetic EMF, which causes an oscillating electric field. Thus, an oscillating charge produces the electromagnetic waves, and the direction of E and B are perpendicular to each other and always in the same phase. Propagation of electromagnetic wave is always along E cross B. Now, for better understanding of the electromagnetic waves and dealing with it, we are here taking an example that let if electromagnetic wave be represented by E is equal to 3.1 Newton per Coulomb cos 1.8 radian per meter y plus 5.4 into 10 power 6 radian per second into t whole multiplied by I vector. Then as the general equation for electric field along positive x-axis is given by E is equal to E0 sin E0 cos within bracket ky plus omega t into I. Then on comparing these two equations given above, we find that amplitude of electric field E0 is equal to 3.1. You can see there, and angular frequency omega is equal to 5.4 into 10 power 6 radian per second. You can see there, and wave number k is equal to 1.8 radian per meter. You can see there, compare here, k is there and also 1.8. So, and wavelength lambda is equal to 2 pi by k. We have already calculated k, so we get the wavelength of the electromagnetic wave is equal to 3.5 meter. Now the frequency nu is equal to omega 2 pi, and we already know the value of omega as calculated above, and dividing by 2 pi we get 0.86 megahertz. So amplitude of magnetic field if is given by the relation E is equal to BC, therefore B0 is equal to 0 by C, and we put the value of E0 which we have already obtained there, divided by the speed of light in vacuum, so we get 1.03 10 power minus 8 Tesla. So in general, the equation for magnetic field vector is along say negative y-axis, and that will be given by B is equal to B0 cos kx plus omega t into k. Thus, for this way we may write the magnetic field vector equal to, we know the B0 we have already calculated above, and we write k, for k we have already got the expression 1.8 value, so radian per meter, and then then we have omega value already there. You see, we have calculated omega is equal to 5.4 in 10 power 6, and that value is placed here into t. So that way we got the expression for magnetic field of this wave. Now the reverse process, if we are given the magnitude of electric field and we are also given the frequency of electromagnetic wave, then in that case we would like to find the expression for the electromagnetic, the equation for electromagnetic wave. How we are going to do it? If we are given the amplitude of electric field is 120 Newton per coulomb and frequency is 50 megahertz, then from this relation we can find the value. Then we can find the value of B0, which is equal to E0 by C, and we know the value of C, so it becomes E0 that is known to us divided by C, that becomes 400 nano Tesla. That means 400 into 10 power minus 9 Tesla. And as the omega is equal to 2 pi nu, we have 2 pi 2 into 3.14 multiplied by nu. We are given the value of nu, that is 50 megahertz, so into 50, and megahertz means 10 to the power 6 factor is there, therefore we get omega is equal to 3.14 into 10 to the power 8 radian per second. Finally, in same fashion we calculate the wave number, and that is 2 pi nu by c, because we can convert this lambda in terms of c and nu. You know c is equal to nu lambda, and therefore we get this value. We are already knowing the value of nu given to us, and value of c is known to us, so we can find the wave number value 1.05 radian per second, and wavelength will be c by nu. So we can find the wavelength, that is 6 meters. And once we have calculated all these, we can write the equation for electric field for the electromagnetic wave and magnetic field for electromagnetic wave as using the expression. This is the general form of expression, B is equal to B0, and if we write in terms of cos, then we have E is equal to E0, that is 120 sine, and then we have the value K K is there already, and so on putting this we get these relations. Thank you and have a nice day.